We are Foresight OT. Foresight OT stands for Operational Technologies. The OT cluster provides key for IR technologies and services needed to help industrial customers with their full end-to-end digital transformation journey, while following a cost-effective, low-risk and self-funding methodology. This allows customers to remain competitive in the digital economy, while making sure any digital initiative has a 6-month, or better, return on investment. We combine digital technologies, artificial intelligence, data analytics, and a well-trained workforce. Together we accelerate digitalization across the value chain to bring you a safer workforce, greener energy efficiency, longer asset reliability, and faster productivity. We encourage our clients to continuously innovate to generate significant sustainable growth. Contact Foresight OT today.
All right, welcome everyone to this presentation. We are from SET, that's Simulation Engineering Technologies, and the topic of our presentation today is representing a system using discrete entities, flow, or tokens. So just a little bit of background on SET specifically. We specialize in simulation models as a way to mirror what is happening in any type of business process or environment. So we try to get it to behave in a similar way than the current system, but everything obviously in a virtual environment. So what this allows you to do is improve your decision making by allowing you to test various scenarios based on capacity, throughput, unplanned failures, maintenance, all of those different things we include in our typical types of models. What this also allows us to do is help identify bottlenecks and basically just aid businesses in increasing their throughput, being more effective in the way they are currently doing business, saving money, increasing throughput, everything you need to essentially make more money. So the focus of today will be to show you how the same type of system can sort of be represented in different kinds of ways. So we have discrete entities, which is the base point of Simio. The standard library is very well set up to deal with those kinds of things. We have literal discrete entities moving one by one through the system through different processes. With the flow, what we are aiming to do is have a more approximated type of approach, and then tokens, that is for your bit more advanced type of users, but we are going to show that just to have a complete comparison of these different types of ways to model similar systems. I'm going to be handing over to Zamri now. She will be, she's the one who constructed these models and will be taking you through the comparisons of what we learned going through this process, talking to you about the development time that was required for each of these kinds of systems, the types of results you can get out of them, and then also comparing the run speed of these different things. Over to you, Zamri.
Okay, hi everybody. My name is Zamri Kombrink, like Hola just mentioned, and I will be representing the rest of the slides for you. So just jumping right into it, let's say that we have a simple queuing system. We have a teller, and then we have people that arrive and queue at this teller one by one. So my question to you is, how would you model this system? So since the people are discrete entities, your first thought is probably going to be that, oh, I'm going to model this as a discrete system. But just because it's the obvious choice does not mean it's the correct or the most effective choice. So the main question that you should actually be asking yourself before you start the modeling process is, what do I want to achieve using this model? Do you need a detailed model that will be able to provide you with more information regarding your system? Or do you need a simple model that is quickly to construct and will just give you specific results timelessly? So there is a definite trade-off between detail or having a detailed model and then having a simple model that just gives you specific results. And this trade-off is between detail and speed. So having a detailed model is obviously going to provide you with more detailed results. But building a model with a lot of detail is a time-consuming process. So this approach can be used if you have the time and the budget for the model construction and testing. How, on the other hand, If the time and the budget for the project is limited, or if you know exactly which results you're looking for, a simpler model can be built to achieve those specific results, which would save you the time and the simulation effort. Also, another thing to keep in mind when we're talking about speed is a simpler model will run in less time. So you will have an increased runtime speed, meaning that you'll be able to obtain your results faster. Now, to further explain this detail versus speed concept, we used a simple bottling plant and modeled it using three different approaches with varying level of detail. So just to give you a quick overview of the plant layout, we have 7 stations. So it starts with the bottle and scrambler, which is pretty much just the process that lines up your bottles that to go onto the conveyor to your next station, where the bottles are then rinsed, filled, and capped. They then move towards the inspection station, where obviously inspection is completed, and it then flows into your first buffer tank or accumulation table. And pretty much what this buffer tank does is it ensures that the next station, your labeler inspection, has a constant inflow feed so that it's not limited. Okay, and then it moves on to the next buffer station or the next buffer tank or accumulation table, and then it flows to your shrink wrapper. And at this shrink wrapper, it takes 6 bottles and wraps them together and then forms a new 6-pack entity. And then where the 6-pack entity then receives the barcode, and then it moves over to the over wrapper where they wrap 4 of these 6-packs together, creating a final product of 24 bottles wrapped together. Now, just some basic logic that is also included in this model is we have work schedules, random component failures, processing times per station, and batching logic. Okay, so like I said, we use 3 different modeling approaches to further explain the concept of detail versus speed. So for our first modeling approach, we use discrete modeling. So this means that we represented a bottle as a unique entity. The model was constructed with a lot of detail, and as you can see, it included 16 properties, 36 states, and 20 processes. The model also uses Simio standard library components to process and transfer the entities. So the standard library brings more detail to the model due to their built-in functionality such as reliability logic or resource states, which is useful for in-depth analysis if it was required. Now, using model entities also allows the user to add specific properties or states to those unique entities. So as you can see, we already have a great deal of results regarding the entities, the workstations, and even the plant's throughput. It did, however, take some time to construct and run the model. So the actual runtime of the model it's relatively slow. So the second approach that we used flow, which approximates the movement of volumes of bottles as a continuous flow. Instead of focusing on processing times at the stations, each station now actually has a flow rate of bottles per minute or bottles per hour, depending on how you wanted to analyze it. You can see that the model uses less detail. It uses 6 properties, 15 states, and 17 processes. The model is also simplified by using flow nodes as the workstations instead of the servers, as used in the previous approach. So these flow nodes do not have those built-in functionalities such as the reliability logic or failures and the resource states, decreasing the level of detail that you can actually get out of the system. So it can be added, but it does require more construction time. So for the flow model, it took less time to construct than the discrete model, and it also has a faster runtime. So you actually achieve your results faster than compared to the discrete model. So for the final approach that we used is we had a token model that we built. So this is where we actually took the entities out of the system completely. So as you can see in the screenshot here that we added, it's literally just the layout of the plant and then the bottles created and bottles packed. So what we mean by a token model is that token and processes are used to control what would happen to the bottles without having any entities in the system. So this approach is definitely for a more advanced users because it can be quite difficult to keep track of and to build. It is, however, much faster to build if you know what you're doing, and the runtime just flies by, so you achieve your results extremely fast. There are, however, extremely limited results. So as I said, you literally only have what the bottles that are created for your system or flowing through your system, and then the bottles that are packed. So it's pretty much the throughput of your system, and then the bottles or the number of entities that flowed through each system.
Okay, so this is our discrete model. So as you can see, there is a lot happening within the facility view. We make use of Simio's basic or standard library. So the basic components such as a server, a transfer node, a basic node, a combiner, source, a sink, and a resource. So now to just show you quickly, if you press play here, you can actually see the entities arriving one by one. So if you also want to see it in a three-dimensional view, you can see that as the bottles are created, they are now lined up. So the bottle unscrambler lines the bottles up on the conveyor so they can flow to the next system. So what is nice about the discrete model is you can actually see the state of your workstations. So for example, this workstation is currently busy. So all three of these workstations are busy. So they show the color green. Whereas the rest of them are still waiting for inputs, so they are currently idle. So just to fast forward this a bit. So just to show you as well, at these combiners, so we have a shrink wrapper. So this shrink wrapper takes 6 bottles and then wraps them in those packs of 6. So as you can see, we go from a bottle entity or a bottle animation to a 6-pack animation. So that's also another thing that's nice about the discrete model is it depends on how much animation you actually want to add to your model. So how pretty do you want your model to look? So after the bottles are packed in 6, they go to the barcoder where they receive their barcode, and then from there they go to the overwrapper. So the overwrapper just combines your 6 packs into 4s, or they group them into 4s. So that means that your final product is 24 bottles wrapped together. Okay, so just another thing to pay attention to is if I try to fast forward this, so this is merely for a day's run, is the run time, it can take some time. So as you can see, it's not just rushing through quickly, it actually takes a while to process. So once again, detail versus speed. So a lot of detail, it looks nice. You can easily track your entities flowing. You can easily see where there is a blockage or a failure or a problem, but it takes some time to actually run through the system and to generate the results. Okay, now switching over to the discrete and flow model. Flow and token model. Okay, so this is the flow model. So as you can see that it is a little less detailed or a little less happening or a little less is happening in the facility view than in the discrete model. So instead of having the actual standard library components of Simio, we are now using flow nodes. Now, this means that this flow node is looking at a rate, so bottles per minute, instead of having a processing time of, say, 5 seconds per bottle. So with the flow nodes, we no longer have that pretty visualization of, okay, the station is busy, or it is failed, or it is idle, or something like that. So this functionality can actually be built in, but you won't see it in the facility view. You can actually write it out in your results, but it's going to take some extra developing time to actually achieve that. So it has exactly the same functionality, it just looks different. So if you actually play this model a bit, okay. Okay, so if you actually play this model, you can see the flow of your entities through your entire system. So you can see where your entities are gathering. So also a nice thing about this is, for example, if your model gives you an error, it's nice to actually go and see, like, is there actually flow going through my model? Where is it blocking? Where is it getting stuck? And you also get to measure your outputs of your system. So just to show you that even though it's not as quick, the runtime is also, it's a bit faster than the discrete model. So it's going to take you less time to actually gain or get to your results, to actually see what's happening in your system than with the discrete model, even though you're going to have less specific results or less detailed results. Now for the token model, to just switch this over to token. So this is the extent of what happens in the facility view with the token model. Everything, all the logic is in the process. It's in the back end of the model. So all these processes labeled as T is everything that, this is your logic for your token model. So if I play this, you can literally see that it's counting the amount of bottles that entered the system and your 24 packs that are exiting your system, so your throughput of the system. So if I fast forward this, you will see the runtime is exceptionally faster than both the flow and the discrete model. The only issue or the only hassle with this is, as you can see, there's no way to actually track whether or where the model is getting stuck. So if you get an error, the only way to actually find your problem is by switching on your model trace to actually try and find out where things are getting stuck or in which process the issue is, or to try keep track of your tokens, keeping track of your tokens that flow through your processes and where they actually are. So like I said, the results with this is very limited. You can only literally see the amounts of bottles that are created for your system and your throughput.
Okay, so now for the results. So we're calling these the general results because these are the basic results that can be achieved by all three of these modeling approaches, so the discrete, the flow, and the tokens. So these are very, very basic like results. So it's literally just the bottles that entered your system, the total bottles packed at the end of your system, so at the end of runtime for each day. So that's pretty much the throughput of your system. And then also the total bottles that remain in your system. So the bottles that remain in the system are due to the work schedules that we defined in the model. So the work schedule runs from 8 a.m. to 5 p.m. and includes a 30-minute lunch time. So during the lunch and after the shift, the stations will stop processing the bottles that are currently at that station, which then leaves those bottles in the system until the next shift. So that's just the way that we modeled this system. But there is, however, an option to say that you want your stations to first complete the work before going off shift. Okay, so now for the next result. So these are discrete detailed results. So these are specifically to or from the discrete model. So as you can see, it gives you a lot more detail. So we can, for example, see the breakdown of your workstation utilization. So how busy or how idle is each workstation, or how much time does it spend in failures? So for example, here we can see that the overwrapper and the barcoders, for example, is severely underutilized because it spends the majority of its time in an idle state. It also allows us to evaluate queue lengths and the queuing time. So as you can see that the queue length or the longest queue is at the labeler inspection station, which probably means that it's the bottleneck. So also these kind of result data allows us to actually do a bottleneck analysis. So therefore, once again, the more time that you spend putting or constructing detail into your model, the more detail you're going to be able to get out of it. So for the flow model, we can, for example, actually also add this kind of like the process logic on your flow nodes and also gain these kind of results, but it's going to take more time. So just looking at the actual results achieved by each approach. So you can see that for each of these models, we achieved the similar kind of throughput. So all of them kind of reached about 74,000 bottles that ran through. the system. But you can also see that the light blue line is the runtime. So it's actually the time that it took the model to reach those results. So you can see that. So once again, yes, your discrete model is extremely detailed and it gives you all those amazing results that I showed you on the previous page, but it took a very long time. Whereas compared to the token model, it gave you very, very basic results, but you could achieve those results and actually come to a conclusion a lot faster. So if you're just looking for specific results, then it's going to be like a lot more clever or a lot smarter to actually just use the token model or build a token model or, well, build a simpler model. Okay, so just to look at some hard numbers. So looking at a comparison between the development and run times for each approach, the discrete model obviously had the longest runtime. Now the flow model, its runtime is reduced by 68%, which means that it was 68% less than that of the discrete model's runtime. So once again, it's faster. And as you see, the token is 90%, 95% less than the runtime of the discrete model. So once again, if you need faster results, simpler model is the way to go. So for the developing time, the discrete model took about 1 week to develop. And then also because it provides you with so much information that you can get out of the model, it took about 1 week for us just to actually construct those nice dashboards and actually just clean up the results and see what you're looking for, and then have that pretty looking dashboard. So also another week. So once again, yes, it's great to have a lot of results and a lot of data that you get from the model, but you're also going to have to clean it up and actually make conclusions from it, which is not always easy. For the flow model, it took 1 week to develop, so it was really fast and also had very basic results. So you could literally set that up within a day or two. Whereas the token model literally took 2 days to develop because it's all processes. There's no logic within the facility view, no extra properties or anything like that. It was literally just processes that can be tracked. So very, very quick. But just to restate, it is definitely for a more advanced user. For example, while building this model, if you get stuck, you have to open up your trace or actually go and watch your entire model to see where your tokens are. So it's a lot more difficult, whereas for your discrete or your flow model, you can just go into the facility view and see, okay, we don't have flow after this station, which means that the problem is probably there, and then it makes the trace process a lot easier. So so all of these things are something to keep in mind. But I hope that you guys enjoyed this presentation. I actually got something from it today. Thank you so much for listening to us. Any questions?
Hello, can you hear me?
Yes.
All right. Well, as Adam's working on the audio, I'll jump in. Can you elaborate on how you select the modeling approach given the scope and objectives of a particular project?
Well, I think it will basically come down to what it is you hope to achieve through the project. What are your timelines for developing? And then also what are the types of results you want to get from it? If it's a simple one solution type of approach, if you just want to know, for instance, in this example, how many bottles can you process given a day or a week, then the token approach is more than sufficient. But if you actually want to go into more detail, get more results out of it, that will ultimately determine the approach you would take.
Thank you. Another question about the trade-offs between details and speed. While considering the trade-offs between detail and speed, was memory considered as well? That is, how much information was necessary to store in tables or properties to make this work?
Yes, not in such a detailed sense of the word, but in essence, yes, we did consider that. So as Zamri showed in a little comparison with how many properties and processes are required for each of the approaches, the token one use the least memory flow was second, and then the discrete model used the most.
Another question, kind of going off an idea we built yesterday. Are these models data-driven? If they are there many differences between the data used for each model?
Okay, so these are not explicitly data-driven. Mostly we just use the data to control the processing times for each of the stations, for instance. So it's not per se data-driven in that sense. But ultimately, in a sense, yes.
Nice. And we have a lot of questions about your model. So how does the performance of the model compare in terms of debugging? Were some approaches easier to debug than others?
Somebody, would you like to answer that one?
Yeah, sure. I think this depends on your skill level, so like how familiar you are with Simio. So for example, with the discrete model, it can take some time to actually try and figure out where the problem is if you're using the trace, because there's so many components and processes already in use. So because of the level of detail, there's a lot of data to scan through when you're looking for a bug. But in terms of the token model, for example, it was a lot easier if you know what you're looking for and you know what you're doing. It's a lot easier to find.
So this is another question about the bottlenecking in the models. Are the simpler models capable of identifying process bottlenecks?
Just one of the things also to note there is... Sorry, Eric.
No, go ahead. Sorry. Right. Are the simpler models capable of identifying process bottlenecks, or are there improvements opportunities for the system? Seems like... All right, seems like we're having some audio issues with this presentation. I apologize for that. I will share Hada Zamrai. Can you hear me now? I apologize for the audio issues for this presentation, but we'll share your contact information in the in their description so people can reach out to you directly, and we'll share more questions and answers there. But I want to thank you guys so much for presenting at Simio Sync. I know SET, you did presentations twice. Thank you so much for presenting, and have a great rest of your day.
Thanks, you too, Eric. Thanks for having us.
This concludes this presentation. Please click on the back button to access the next presentation.